This video is about replacing special relativity in the scalar theory of everything. The STOE starts from Newtonian optics, interprets experiments since Newton, examines data, not the standard conclusions, and the goal is to explain a wide scope of observations by theory postulates such as galaxy redshift and the Pioneer anomaly, explained by one equation. The STOE model is causative for forces that cause changes. It is Machian. It is fractal, that is to say all size scales are similar concepts and equations. The physical laws are the same everywhere in the universe. The issue is to discover those laws, making an infinite universe difficult to conceive. A previous episode of the CNPS had the introduction to the scalar theory of everything. And of course, there's a paper on the subject here. This video explores how the STOE applies to the SR basic observations. Note the data here, not the SR theory. This video suggests measurement should be in relation to a plenum density and the gradient of the plenum density, the rho. This triggers the Machian and causality characteristics of the universe model and the relation of observations of the big, the classical, and the small size scales. And the development of special relativity is based on observations from the 19th century, that is to say, of index of refraction, which is Fitzhugh experiments and the aberration of light, the negative aether drift experiments, that is to say, the Michelson-Morley experiment, and the resulting in the observations, which suggested the Fitzgerald-Lorentz equations. And of course, it also included Maxwell's equations, and in particular, something called the moving magnet and conductor problem, which is a thought experiment. You may remember in the last video, the photon simulation of a single slit diffraction. Here are photon paths. Here are the photon paths through a single slit. And you'll notice, as we noted in the first video, that the photons start to deviate from their path just before or close to reaching the slit, such as you see here. Here we follow the photon's path as it gets close to the atoms, these things, in the slit, and you'll see that they generally change direction, and this should be somewhat similar to the Huygens model. You may remember the explanation of coherence in the photon simulation from the first paragraph. So here we see a couple of photons, here and here, and they're traveling in a row. In the higher row density, the photon speed is faster than in the lower row. Therefore, in time, they tend to line up, which is what you saw in the first video. That lining up is coherence. Another experiment which demonstrates this carry-along effect is the Fitzhugh experiment. C is increased when in the direction of fluid flow, and is decreased when against the fluid flow. That is, the immediate environment of the photon determines the photon's speed and trajectory. Now, you note this is carry-along, not drag. That is to say, the speed of light is dependent on the rho. The greater rho causes greater tension in the plenum, thus has a higher speed of light. As the Fitzhugh fluid body moves in the direction of the photon spends more time in the relative peak, that is to say, it travels faster. Thus, the photon is carried along at a slightly greater speed dependent on the refractive index. And the Fitzhugh fluid body moves in the direction opposite to that of the photon spends more time in the relative valley of the rho. Thus, the photon is carried along at a slightly lesser speed dependent on the refractive index. Here we see a graph presented in the Michelson-Morley paper. And what you'll notice here is that the big differences appear to be right in here and right in there. Now, you may remember where they are. They're in north latitude. Their tabletop where they're doing an experiment is roughly flat to gravity. But if you look at the straight east-west direction is virtually null, which is, okay, it's virtually null. And where the direction is roughly equivalent to where the sun-moon combination is directing opposite. That is to say, this area and this area seems more related to tides than they are to motion of the Earth. So you see, they did detect a difference, but it was a very lower value compared to what they wanted. And it was in a different direction. I say sun-moon direction rather than Earth motion direction. So I tentatively suggest it's the result of a carry-along effect. So experiments rejected the notion of a wind, but not of other ether models. That is, ether is not particles. The world of the sun and moon was at right angle to the effect. Thus, it is a rho effect. The theory of the luminiferous ether behind the Michelson-Morley experiment is inconsistent with the Fitzhugh experiment. No deviation in the direction of Earth's movement, but the difference was noon and midnight, and so the luminiferous model was rejected. But the STOE does have a form of length contraction. And here it is. Here we have a rod and an observer. And we note the center of mass of the rod is right there. We're going to refer to that later. Here the rod has moved in a slightly different position. This is a light ray that was emitted when the rod was in its old position, and the light ray is traveling towards the observer here. Here's another light ray emitted at the current time from the end of the rod, and you'll see that the distance from here and to there to the observer is the same, which means these two rays arrive at the observer at the same time. Thus, the observer believes that the rod is shortened by that amount. So we see here that the measured distance by the observer is dependent on the speed of the communicating thing. If it was other than light, such as sound waves or plenum waves, you would get a different result in terms of its measured length in the observer frame. So here we view where an observer would view the center of mass of the length of the rod to be. If he observes by light, he expects it to be slightly off from the center of mass. If he observes by gravity speed, which is millions of times faster than the speed of light, he would observe it to be very close to the center of mass, which is here. Measuring it by gravity speed is how Laplace and Van Vlinder measured the speed of gravity. Remember all the videos on CNPS that suggested the physical parameter changes caused by velocity, and only velocity, that is to say moving frames alone in the moving frame produces paradoxes. Well, however, a measuring frame may measure changes without such paradoxes, as we're suggesting here. So length contraction caused by velocity is not real. However, we do know that length contraction can be caused by other things such as temperature, etc. The Michelson-Morley experiment was a carry-along effect of near bodies, that is to say the tables, the room, and the sun and the moon. But measurement of shorter lengths in frames moving with respect to systems is real. That is to say, real in that the measuring system measures it to be real, even though the length of the rod is not actually changing. Maxwell's equations suggest fields that transform according to Lorentz invariance. The STOE posits hods are permanent magnets. that EM radiation signals are hods because they travel at the speed of light. And we note that the Coulomb force, which has been measured at many times the speed of light, therefore the Coulomb force is a plenum effect. Here are measurements of the Coulomb force. This is the older paper, but here's a paper where they looked at several different experiments. The moving magnet and conductor problem is a thought experiment which Einstein considered, and the statement of this thought experiment is that observable phenomena depend only on relative motion, the key here being relative motion, but the customary view of Maxwell's equations draws a distinction between which is moving in a stationary lab frame. Stationary is the special relativity term. The STOE substitutes the word measuring for that word stationary. The STOE rejects thought experiments in general, meaning they should not be used to develop physics models. They may be used to explain physics models, but not to actually develop them. And the STOE rejects Maxwell's equations, and we're going to go into that here in a little bit. There are two types of magnetic field that we explored in the first video. One is where the divergence of that magnetic field is equal to gravity. This is a permanent or hod magnets, right? The other type is electromagnetic field, in which case the divergence is zero, as Maxwell suggests. There's an inconsistency between Faraday's law of induction and Ampere's circuit law. We're going to test the Biot-Savart law. In the first video, we had two tests for it. I'm going to repeat one of the tests here with a few extra comments. The STOE suggests the magnetic effect is ejected from the wire perpendicular to the wire, not in all directions, as the Biot-Savart law assumed with its cross product. This is also experienced in the directionality of radio signals from, say, dipole antennas, which suggests a speed limit of the speed of light. The STOE suggests the hods have a magnetic field and travel at the speed of light. It's the hods that are ejected. This is how we're going to test Ampere's law. Here we have a circular current flow in wires, and an element of that length of wire right there. And what we're going to concern ourselves with is the difference between the perpendicular, which goes through the radius, which is DC, and not along R. Of course, the STOE says this current element induces a magnetic effect along its length. And the Biot-Savart law says this R should also be included. You will note in this diagram that this is the magnet here, that it is not affected by DC, but it is affected by R according to the Biot-Savart law. This is the Kronecker delta. So if the magnet here resides in some zone that is perpendicular to the current flow, like in this zone, then it's going to have an effect. If, on the other hand, we're concerned about an element down here, for instance, this will have no effect on the magnet because it'll be directed towards the radius. However, the Biot-Savart law says this element should have some impact on the magnet, even though it's over there. So we're going to do measurements. And here's how we're going to measure it. This is a weight scale. Here we have several disc magnets, ceramic disc magnets. We put them on a wood block so that the magnetic field doesn't impact the scale. And this is our setup. So here we have the circular wire wrapped several times around the center area, power supply putting a current through the wire. This is the vertical of it. That is the magnet with the scale in the middle of the circle, but at the lower edge of the electromagnet, which we're creating. This is the center position of the zero position. And here we have the magnet near the edge. The Biot-Savart law says that the magnetic field at any point compared to the center, which is what this scale is, should look something like that. The STOE says no, because remember all that area that didn't have any overlap with the magnet with a larger DM, that should look like that. And you can see that the actual data, these little triangles here, comes pretty close to the STOE model and rejects the Biot-Savart law. Now we test Faraday's law. Here, what we're going to create changing magnetic field by simply dropping magnets through the coil, as you see here, and we're going to measure the voltage as the magnet drops. It'll be kind of a fast movement. The voltage measured from the dropping in the center and the edge was the same. That's to say, the magnetic field induction is dissimilar to the electric field characteristics. Calculations using the Biot-Savart cross product or the Ampere circuit law are incorrect. There are two different types of magnetic field. One is produced by current, and these are hods being emitted from the wire, hods being magnets, and the other is the permanent magnets, which is a plenum effect. Free space in the STOE is the plenum without hods. Now, there's an issue here. So a vacuum in a lab is surrounded by walls, which are hods. Thus, the plenum density at a point is modified by the hods matter around the point. But the plenum is ontologically real, you see, and so it is not a true vacuum, meaning devoid of all real things in our universe. It's a vacuum is where there is no hods. In relativity, space-time can be warped and it can direct matter. This is the plenum, or aether in other models. That rose by any name is still a rose, you know. But space-time, that is to say the left-hand side of the field equation, is a result of a math mapping. The S and T are fictitious parameters with no real physical meaning. That is, space-time must be inverse mapped to calculate experimental observations. Therefore, measurement of the speed of light using the left-hand side is invalid. The maximum they can measure on the left-hand side is C. So when you transfer it back to be the real side, meaning the energy, stress energy side, it ends up being something greater than C, which is what is measured. Let us try to conceptually consider the meaning of these two proportionality constants in the STOE. We consider an analogy with a string, that is to say, the velocity of a wave along the square of the velocity of a wave along the string is proportional to the tension on the string divided by its inertia per unit length. It's the inertia that keeps the string moving in its oscillation. So by analogy, we have the speed of light. Now, we may remember from previous presentation, the hod is a magnet which warps the plenum density, which then causes the gravity observations. That is, the hod causes a tension field in the plenum density. The plenum has the property of inertia and is the inertial mass of bodies. So the tension is analogous to the inverse of the magnetic constant. That is to say, the speed of light squared is then the inverse of the magnetic permeability divided by the electric constant. The operational meaning then is behind the magnetic tension or pressure and the electric resistance is the perpetual movement of plenum wave triggered by the movement of the hods. Perpetual meaning friction is not in the plenum wave, friction is in the loss of hods. These waves in the plenum then cause hods to move. That is the one and only force in the STOE. The Shapiro delay experiment looks at the rate of hod movement far from the sun and close to the sun, and so photons travel slower in the lower row around the sun. The speed of gravity, which is the plenum speed of waves, Laplace measured it some time ago by looking at satellites, planets. Lorentz, Poincare, and Einstein measured it at the beginning of last century or so, and they measured it at sea. But again, what they're doing is they're essentially looking at the left-hand side of what turns out to be the general relativity field equation. Van Flanderen measured it at millions of times the speed of light. He redid Laplace's calculation with modern data and equipment. The Coulomb speed is the plenum speed, and of course we saw this paper before, but it is much greater than c, but in the Shapiro delay it's so fast that they really can't measure it, how fast it is. It's just very much faster than the speed of light. Another plenum speed application is in quantum entanglement, which is suggested spin. Well, spin is so they can use the angular momentum math. But what the STOE suggests in these experiments is that what's really going on is the inherent magnetic pole of the particle is actually being reoriented to the magnetic pole in the experiment rather than any kind of angular momentum. Einstein, with the PR experiment suggestion, and Bell in his inequality, attacked the superposition, which is a linear assumption of quantum mechanics. This is Schrodinger's cat thing. That is to say, a state of a system is undetermined until you actually take a measurement. Well, that's a very core idea of QN, but it's not quite right. John Bell looked at this analogy and suggested that we think of socks. So you go to a mall, you ask to see the sock color of someone on the right foot, someone you don't know, it's all, if you want to really do that. Then you suggest that the left foot color sock is the same as that he saw on the right. So if the right foot sock color was red, you say, oh, well, the left foot also has a red color on it. This is a legitimate quantum mechanics experiment. You don't know whether the cat's alive until you open the box. Well, you don't know the left foot sock color until you look. But the hidden variable is that the socks were determined when they were selected. It is not a linear superposition. Bell's inequality that hods cause plenum waves that cause direction of the hods. In Bell's inequality, the hods cause plenum waves that cause the direction of hods to change. This is the hidden variable. And of course, the plenum wave travels much faster than the speed of light. See, the STOE model of photon interference, which explains the transparent mask experiment, which no other model does. The plenum density wave travels at the velocity of gravity, gravity being another effect of this interaction. See how the unity of QM and the big is taking shape. Therefore, all interactions are at plenum speed. They're all non-local in the sense of Bell's inequality. Entanglement, then, in the STOE model, is wave and particle effect. Plenum wave speed directs the light and has a speed much greater than the hod or the photon speed. The photon causes waves in plenum, which is dependent on the number of hods, energy in the particle. Time dilation, another special relativity thing. In the STOE, space and time are passive backdrops where the events of the universe play out their trajectories. Space allows movement to and fro, right? You can go to or from some objects. However, time is in only one direction. That is, say, the arrow of time is duration between events. Therefore, processes are not symmetric, as current physics of the time parameter suggest. Instead, they talk about entropy, and then the major theories, quantum mechanics and general relativity, really don't think too much about entropy or friction. Science works by using standards which, by assumption, are constant in the experiment. This is usually false, but the uncertainty is within the limits, which makes the resulting model usable. Usable works by allowing uncertainty adjustment, such as done with a GPS system and in the flight of spacecrafts. Measurement standards should be constant for observations for which they are used. Even better, they should be constant throughout the universe, but this has to be assumed. Consider the speed of light as constant results in increased complexity and disagreement with some observations. Space should be measured with rods, but rods may vary with conditions such as temperature, but we know of that variation. Clocks are assumed, they're designed to produce a uniform duration between ticks. Now, a tick of a clock has a physical process that is repeating, and then a counting mechanism, and then you have the assumption that between each tick is the same duration. If either varies, the uniform assumption is violated. Therefore, the use of clock is really just comparing one physical process with another. The time abstract concept is a misinterpretation in physics. The pendulum process has the advantage that we understand the process and its response to various conditions, such as acceleration or forces, plenum density, and, of course, radiation. The atomic clocks that are frequently used these days has the disadvantage that we do not understand how the decay process works or what triggers the theoretical random process. However, decay processes have been noted to vary annually, and this is not generally known, but here are some papers. This is a guy that has investigated these quite a bit, and you generally don't see this kind of stuff published, but it nonetheless exists and is real. I would speculate that the neutrinos from the sun trigger nuclear decay, but that's just pure speculation on my part. Time dilation in STOE is due to changing speed of light. That's to say, in the Shapiro delay, what's really happening there is not a time dilation, it is a changing speed of light between the two paths. The atomic clock variation in differing conditions should be considered as data in a model of a future physics decay process theory. The experiments that were used to develop the special theory of relativity were examined in light of the scalar theory of everything. The special theory of relativity should be replaced. The speed of light is the fastest any body can travel and is dependent on the plenum density. Thirdly, the laws of physics are the same everywhere. You may remember in the STOE that all particles are subject to the force of the plenum, that's force, so therefore there is no absolute frame of reference, seeing as all that plenum density is developed by everything in the universe, and there is no Galilean, that is to say, constant velocity reference frame. All particles have a force.